Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Marsumaki Abdurrahman. Our topic is about digital logic review. Introduction. Digital logic review is the process of the studying, recalling, and practicing the basic concept of digital logic to better understand how digital system work. My topic is logic gates. Logic gates is a fundamental physical device or digital circuits that perform a specific Boolean logical operator and or not, etc. One or more binary inputs 0 and 1s to produce a single binary output. Logic gates is a fundamental of physical device. When we see physical device like hardware, example, mga monitor, mouse, keyboard, or digital circuits that perform a specific Boolean logical operator. When we see logical operator, amo na mga and or not, etc. So, on one or more binary inputs 0 and 1s to produce a single binary output. Yung pagyanon logic gates ini ay electronic circuits na ginagamit sa digital system at computer para mag-process ng data gamit ang binary number 0 and 1s. Yung binary number 0, 1s, kahit yan lang sin computer, bangin language niya 0, magiging off siya or false. Yung 1 at saka 1, magiging 0 siya or true. Of logic gates, amunan N, or, NIN, NOR, XOR, XNOR, NOT. So, ayan rin ang mga symbols niya. Types of logic gate function. Number 1, AND. Output is 1 only if all input are 1. Number 2, OR. Output is 1 if at least one input is 1. Number 3, NAND. Opposite of N. Output 0 only if all input are 1. NOR. Opposite of OR. Output is 1 only if all input are 0. XOR. Output is 1 if input are different. XNOR. Output is 1 if input are the same. NOT. Invert the input 1 become a 0, 0 become in 1. So, truth table, possible combinations, input at saka output. So, example, mag-switch ka light, button 0 and 1, button on and off. Example of AND gate. Then, A and B, mag-represent siya input. So, E is 0 and B is 0 and output niya is 0. E is 0 and B is 1 and output niya is 0. E and 1 and B is 0 and output niya is 0. Then E and 1, B is 1 and output niya is 1. OR gate. Output is 1 if at least one input is 1. So, example, A and B or A plus B. So, 0 plus 0, and the output niya is 0. Then, 0 plus 1, and output niya is 1. 1 plus 0, and output niya is 1. And 1 plus 1, and output niya is 1. Basta siya on input B is 1 or E, mag-output siya is 1. So, number 3, NOT gate. Output opposite of input. E represent the input. E is 0, mag-output is 1. E is 1 and output niya is 0. Number 4, NAND gate. Opposite of N. Formula A and B. E and B represent of input. E is 0, B is 0 and output niya is 1. E is 0, B is 1 and output niya is 1. E is 1, B is 0 and output niya is 1. E is 1, B is 1 and output niya is 0. Number 5, NOR gate. Opposite of OR. Formula E positive B. E and B represent of input. E 0, B is 0 and output niya is 1. E is 0, B is 1 and output niya is 1. E is 0, B is 1 and output niya is 0. E is 1, B is 0 and output niya is 0. E is 1, B is 1 and output niya is 0. XOR gate. Output is 1 if input are different. E and B represent of input. E is 0, B is 0. E is 0, B is 1 and output niya is 0. E is 0, B is 1 and output niya is 1. E is 0, E is 1, B is 0, and output niya is 1. E is 1, B is 1, and output niya is 0. Number 7, XNOR gate. Opposite of XOR. Output is 1 if input are same. E and B input. E and 0, B is 0, and input is 1. E is 0, B is 1, and output is 0. E is 1, B is 0, and output is 0. E is 1, B is 1, and output is 1. Conclusion of logic gate. Logic gates are the basic building blocks of digital electronic and computer system. They perform simple logical operator using binary input 0 and 1 to produce an output. Each type of logic gate such as NOR, NOT, NAND, NOR, XOR, XNOR has specific rules that determine the input based on the input value.
I am the next reporter, so my topic is combinational circuit. A combinational circuit is a type of digital circuit. It's where the output depends on the current inputs. So combinational circuit, it has no memory. That means it does not store past values. Whatever the inputs are right now, that immediately determine the outputs. So, in example niya, mga half adder, full adder. Kasi ang combinational circuit ginagamit kapag ang output ay kailangan mag-depend lang sa current outputs. Kasi ang combinational circuit ay walang memory at walang phase state. So, type of combinational circuits. Arithmetic circuits used for mathematical operations. Biasin mga plus, minus, iban sin mga multiplication. Basta type sin mathematical operations. Number 2, data selector circuit. Select or route data. Bali, in data selector, biasya switch o tagapamagitan siya na pumipili kung alin data ang ipapadala sa isang particular na destinasyon. So, number 3, data conversion circuits. Convert signal into another form. Examples, it's like digital thermometer or digital camera. Ginagamit ito sa mga device tulad ng digital thermometer at digital camera para i-convert ang tuloy-tuloy na signal. Number 4, code converter circuit. Converter one code to another. Examples, biasin binary to gray code converter. Ginagamit ito para i-convert ang binary code sa gray code na useful sa mga application tulad ng error detection sa digital transmission. Number 5, comparator circuits. Compares two binary numbers. Example, compare A is equals to 101 and B is equals to 011. The result is A greater than B. So that's all. So let's proceed to the next reporter.
Sequential circuits is a type of digital circuit whose output depends not only on the current input but also on the previous state past input. This means it has a memory. Because of the memory, sequential circuits can store information. Characteristics: as a memory, store past information. Output depends on current input. Previous output state usually use lock signal. Boiled use logic gates storage element like flip-flop, all latches. A sequential circuit, general concept of conventional logic, process the output. Memory elements stall of previous state flip-flop latches. Feedback path feed the store output back to the circuits. Two type sequential circuits. A Asynchronous sequencer circuits controlled by a lock signal change state only at specific lock time. More commonly used digital system. Example: counter, set, register, register. Counter is a type of the digital circuits use electronic the counters. First all event it is commonly used in device like clock, time, and computer. Counter number like 0, 1, 2, 3. Since it output very time revise a signal lock force. If a counter start at 0 and device pulse, first pulse in 1, second pulse in 2, third pulse in 3. A shift register is a type of the digital circuits that is used to store and move shift data from one place to other. A shift register store binary data 0 and 1. Move the data left or right when a lock signal is offered. Register is a basic digital component used in electronic and computer to store group of bit binary data. Small memory units used to hold data temporarily. Mother of several flip-flop. It as flip-flop in store 1 bit. Asynchronous sequencer circuits not controlled by a lock. Output sends immediately when output sends faster but under to design. Example: flip-flop is RGK DT counter shift register memory units. Memory units is a part of the digital system like a computer that is used to store data and information. And store data, introduction and result. Type of memory units: primary memory, main memory, directly used by the CPU, but smaller in size. Example: RAM, random access memory, temporary storage, data is lost when power is off. ROM, read-only memory, permanent in storage, data is not erased chance. Conclusion of sequencer circuits. The sequencer circuits are the initial part of the digital system because they can store and process information over time. Unlike conventional circuits, their output dependent not only on the current input but also on past state with the help to memory elements like flip-flop and lock signal sequencer. A sequencer circuits are widely used the device as a counter, register, and memory units. Understand how their work is important for designing modern electronic system.
So we are the next reporter for the topic register and counters. So register and counters, essential sequential logic circuit constructed from flip-flops. So yung pagano ni flip-flops guys, ay isang basic electronic circuit na ginagamit para mag-imbak ng 1 bit ng data. So manjari sa bisay ni matawag, 0 is off and 1 is on. So manipulate and account binary data. Register act as temporary pass access storage for manipulate bits using parallel loading or shifting.
Well, counters are specialized register that the increment or decrement track as the specific sequence of the binary state with its clock plus. So, in pagyanon kuno register, kung baga, ini-register ni siya ay magtataw sin data. So, ang register ay isang grupo ng flip-flops na ginagamit upang pansamantalang mag-imbak or magtaw sin mga binary data. So, encounter si sub, ini siya, kung baga, encounter sini, magbilang siya. Ang counters ay isang special na uri ng register na pagkakasunod-sunod kapag nagtatanggap ng clock pulse. So, yari in type sin register. So, parallel. So, in parallel pag yan nini, like mga lalagyan ng data, parallel register, ay isang circuit na iusal or gagamit siya para mag-imbak ng data. So, tinatawag itong parallel dahil sabay-sabay pumapasok ang lahat ng mga bits kapag may clock pulse na. So, the next is a shift register, SIPO. So, ang shift register naman ay circuit kung saan ang data ay gumagalaw o lumilipat sa bawat clock pulse. So, pagtawang day sa binisya, serial and parallel out. Kaya ang SIPO. So, in serial input ni sub, so kung baga, paisa-isa pumapasok yung mga data. So, in parallel output ni sub, sabay-sabay lumalabas yung mga data. So, next is a universal shift register. So, in pagyano ni universal shift register sabi ni, ay mas advanced in register dahil sa kanya nitong gawin ang mga maraming operation. So, kung baga, ini tinatawag itong universal dahil, so, gaya nito, halos lahat ng operation, ang register, universal shift register. So, in universal shift register ini, mas advanced na register dahil kaya nitong gawin ang maraming operation. So, kung baga, tinatawag itong universal dahil halos lahat ng operation ng register. Next is universal shift register. Can shift left and shift right, load or hold data. So, in shift left ini, lilipat pa kaliwa yung data. In shift right sub, lilipat pa kanan ng data. So, in parallel load sub, sabay-sabay maglalagay ng data. In hold, gagalaw yung data. So, yun po yung universal data. So, tinatawag itong universal dahil kaya nitong gawin ang halos lahat ng mga operation ng register. So, okay, next, types of register. So, asynchronous refer counters and asynchronous counters. So, in asynchronous counters ini, so pagtawagon din siya ini-refer counters. Ang unang flip-flops lang direktang tumatanggap ng clock signals ay dumadaan muna sa unang flip-flops bago sa susunod. Yon po yung synchronous refer counters. So, in synchronous counters naman, next is yung synchronous counter. So, synchronous counter, sabay-sabay tumatanggap in mga clock signal lang lahat ng mga flip-flops, kaya mas mabilis, ma-accurate ito. Kaya lahat ng flip-flops ay nagbabago ng sabay-sabay. Yun po yung synchronous counters. So, in up counters, increment the count by 1, 0, 1, and 2 for each input. For example, an electronic voting machine. So, or full bits binary counter tracking 0 to 15, then resetting to 0. Kumbaga, in up counter sini, nagbibilang pataas sa bawat clock signal, all false. So, nadadagdagan siya ng isa. For example, counters. Pag gamiton siya ini, bangkitan yung mga mag-itong. So pataas like mga mag-vote diyan for the electronic machine. For mga mag-voting diyan or mga mag-vote. So nadadagdagan siya bang mga magbilang kita. Like 0, 1, 2, and 3, 4, and 5. Ito yung up counters. Next, down counters. So, decrement the count by 1 and 2 and 0. So in down counters ini like mga kabaliktaran sin mga up counters. So pabawa isab in pagbilang sinyari. Sa bawat signal na babawasan ng isa ang count bali magtag na kita habawa like 9, 8, 7, 6, 5 or 4 hanggang na pa 0. To. So hanggang mahinang sa 0 like basi mga mag-game biyaan. Example, mga di ba magbilang 5, 4, 3, 2, 1 and 0. Ito. So next, up down counter. So capable of the counting in both direction, incrementing or de-incrementing based on a control input. So in up down counter si sabi ni ay manjari kita mag itong pataas iban pabawa depende ha mga sitwasyon. For example, mga parking area yan, so mag parking kita like for example mga car, so kaibanan kasi di ba pagpa-parkingan area like aon maggakanap aon magdaragdag, so biyad to in up down counter. So manjari day sab siya from elevator system or position control. So conclusion, register and counters are important components in the digital electronic register is used to store binary data. Temporary while a counter is used to count clock pulse or signals. So register help and data storage and transfer inside digital system such as computer, where counter are mainly used for the counting operation like in digital clocks and timers. But both circuits are both using flip-flops and play the vital role in the operation of the modern digital device. So that's all. Thank you.